All right, so this last topic, we're going to look at what a matrix equation is and how to solve it. Now before I even show you what a matrix equation looks like, let's just, in our mind, picture what a normal equation is. We usually have, especially if we're talking about solving, we usually have a variable x and then a handful of other different numbers. And then we're trying to get x by itself, so we move all the other numbers around until we have x equals something. So keeping that in mind, take a look at what a matrix equation is. Similar, we see an x. Now it's a capital X, which, remember, capital letters are how we name matrices. So that capital X represents a mystery matrix. We don't know what the data, we don't even technically know what the size is, although because we know addition and subtraction requires all matrices to have the same dimensions, we can pretty quickly judge that this is going to be a 2 by 3 matrix. Why do I know that? Well, because both of my other matrices in this equation are 2 by 3 matrices. Which brings us to an important point. Just like in a normal equation, there are a handful of other numbers. And so we can assume we're going to try to do something with those numbers to figure out what the mystery x value is. Just like in a typical equation, we want to isolate the variable. We want to isolate the x. So looking at this, I say, well, here's the variable. I want to get this by itself. What do I need to do to get x by itself? Well, I'm adding currently this 2 by 3 matrix with 6 different elements within it. So if I'm adding that, I need to get rid of it by subtracting. So just like in a normal equation, if I do something to the left side, I need to do it to the right side. So just to keep it balanced. So subtract this matrix from the left, which is going to make everything just disappear, and subtract it from the right, and we're going to get a new matrix. So let me write that out. 15 and 6. So on the left we have x equals, and on the right we have two 2 by 3 matrices that we're subtracting. So I know I'm going to get the same size for my answer, and now I'm going to compare the pairs of elements. So the 1, 1 position of the first, I'm going to subtract. Now remember, we're not adding, we're subtracting. So I'm saying 5 minus 3. So that's going to give me a 2 in the first position here, in position 1, 1. Going to 1, 2, row 1, column 2. 3 minus 0 is 3. Position 1, 3, we have 12 minus negative 3. So we're saying 12 minus a minus, which is like saying plus, so that's a 15. 12 minus negative 3 is 15. And then I have, going to the second row, negative 6 minus negative 1. Again, minus a minus is a plus, so it's negative 6 plus 1, which is negative 5. Row 2, column 2, so 2, 2 is 3 minus 15, which gives us negative 12. And lastly, we have negative 9 minus 6, which gives us negative 15. And so what we have is x, our mystery matrix, equals, and we have the answer. It's a 2 by 3 matrix with 6 different elements, and if I were to take that matrix and I were to go and plug it back into its original position and add it, we'd end up with a true equality. So we'd end up with the same value on the left as we did on the right, which is, of course, how all equation solution processes always work. So again, we haven't touched on anything too crazy yet. I would say that what's nice about this is it's fairly intuitive. Now we're going to get into talking about multiplication in the next lesson, and multiplication is not quite as intuitive. So if this seems a little bit straightforward, enjoy it right now for addition and subtraction. But as we move forward with matrices, we're going to find that not everything is quite as straightforward as we would assume based on our other knowledge of other types of numbers. But that should do it for lesson 2. You should be able to go and complete your worksheet now.